Everyone, thanks for joining our webinar. My name is Amanda McCarthy. I do marketing here at Ascent Geomatic Solutions. Ascent is a survey and engineering firm, and today we are going to be talking about aerial survey. So with me, I have Nick and Phil. So Nick Cosina has been with Ascent for 5 years. He is our upstream program manager. He manages all upstream clients and all client solutions, which is comprised of Ascent's project managers, And Phil has been with Ascent for 4 years. He is the data supervisor. He manages all the data and the people who work with the data, so our data techs who process, analyze, and deliver the data. So welcome, guys.
Good morning.
Good morning.
All right. So first, we wanted to just kind of give an overview of, what are we talking about here? We're really talking about gathering data to reduce cycle times and cost for permitting new oil and gas locations. So we teamed up with one of our clients who's a large operator in the DJ Basin in Colorado, and we decided we were going to take a different approach at how we go about the survey portion and getting all of the exhibits and the permits ready to submit to the Colorado Oil and Gas Commission. So these typical project areas were, 23,000 or so acres with, up to 18 different development projects. Each development project would consist of 1 to 3 sites. When we compared to old methods, which were about 160-day cycle times, we were able to greatly reduce that. So just a quick look at the different development projects, and then, just an idea of kind of where the pad placement would be, and thinking about how do we quickly gather this data. So with drones, LIDAR, and GIS, basically we've been able to successfully permit hundreds of locations while overall reducing the cost and the cycle times to getting those approved permits. So why drones and LIDAR for GIS? Really what it comes down to is collecting more usable data in less time so that you can better plan a location. The data is accurate, it's collected very quickly, and the biggest outcome of it is improving those timelines as we're discussing. So field data acquisition, how did we go about this? We had 2 different methods that we used over the course of the project. First, we strapped a high-resolution RGB camera to a Cessna type plane and actually flew the entire area. So what this is doing is taking high-resolution photographs that then can be stitched together after setting ground control and tying everything in to be horizontally and vertically accurate. The next bit we did for any areas that had higher vegetation, specific needs for higher density points, we actually went in and used a small unmanned aircraft. In this picture right here, you can see we used, this is an EB. It's just a fixed wing UAV. And, we're able to fly that a little bit slower and really focus in on areas of need. So let's talk about how the survey process was before we were using these methods. Really how a lot of the different survey groups that are out there right now are doing things. So first, client would send us, a quick cartoon, say, hey, I need a 10-acre box right here. Can you go out, get topography, topo shots, let's see if that works, collect everything in the area, and let's start to try to piece this thing together. So we send a crew out and we collect 50-foot grid ground shots, and we pick up the cultural features in that area and continue to go. Next, the client decides, oh well, the landowner doesn't like how this pad is shaping out, so we want to add these areas. Or, possibly there's a ditch or a pipeline scar or something that shows up in that middle area. So we go back out and we collect more ground shots and more cultural information. So that's 2 days of just topo right there. When really what we could have done is fly this on the front end and have all of that data at our fingertips for when situations like this come up. So down at the bottom, you'll see just for a quick comparison, conventional method, in a 50-foot square, we're collecting 4 points. So that's 4 points of data. Sounds okay, but let's see what we can actually do.
Yeah, so for the new method, basically, instead of giving us that small boxed area that the client wants us to go and topo, he'll just give us an entire development plan and tell us in a general area where he wants to survey. And what we'll do is we'll then fly the entire area. And what that allows is then we can create aerial imagery to show them exactly all the new information, pipeline scars and whatnot, but also allows us to create a surface, a DEM off of that aerial imagery. And this way we can then create our contour lines and deliver that to the client. And you can see that the UAV and LIDAR survey, in just a 50 square foot box, we have 2,500 points rather than just 4. So the beauty of this is that now that we have this entire area, we can then extract all those cultural features, all those roads, fences, ponds, etc. We can apply buffers to those cultural features. And then from those buffers, we can then place our pad in the most ideal spot. So in this case, this pad was placed here.
Yeah, so the outcome of all of this is we've taken the time to really talk through with the client, consult on the regulatory setbacks that are at hand. In this case, this was Colorado. But imagine, if you will, any state that you have a regulating agency, really looking at those setbacks, the topography, and then taking in also the landowner's concerns to placing something that's really mutually beneficial for everyone. The end product is really a usable location. It's engineered, it's graded, and balanced. And, you can basically take this pad once it's permitted, going through, the COGCC or whatever regulating agency it may be, and plug it straight into your drill schedule. That's really an advantage there, because a lot of times what you see is you'll get a location, you'll get it through, the COGCC, but maybe you didn't think about, okay, well, how does that really correlate with my facilities group, or my construction group, or my drilling group? This gives you that front end chance to really get that location that you're looking for, that's going to make your life easy, and get you through the permitting process.
So just a little bit about how we store this data and how we deliver it. We use an SDE database for our clients. So each client has their own database, and we store all of their points, lines, and polygons in there. We've got our wells, facilities, bore lines, etc. We process all of our data through TBC, and then through FME tool, we insert all of that into our SDE database where we store it centrally. From that database, we then can edit all of our data with CAD or with ArcGIS. And then also the clients are able to see all of those edits in real time by serving it up to Portal for ArcGIS Online. So any web map that the client wants to be able to view their assets, we can create that for them, and then in real time they'll be able to see anything that changes. We can also deliver those shape files or geodatabases to the client directly if they need it for state permitting and some such.
All right, now the fun times. So let's talk about the timelines for getting an approved permit to drill. Historic average, we took a look at, using the conventional method and just sampled a couple different locations and really just wanted to understand, okay, how long is this taking us? As you can see, we were averaging 160-day turnaround conventionally with all the different visits to the field. The client not being able to really analyze the data and what's going to work best on the front end. Once we actually started using the new methods, we found that we can actually turn a lot of locations around in a much quicker time. Here you'll see over the course of about 3.5 months, we averaged 16-day turnarounds on a bunch of pads. Really just a huge benefit to getting permits in place. In total, we're reducing the cycle times by an average of 144 days. So what are the big business outcomes from this? We have an average of a 16-day turnaround from field to permit submittal. Again, you get that usable location engineered correctly the first time that you can plug right into your drill schedule once it's approved by the regulating agency. We get more data in less time, usable data that you can take directly and plan off of. This data is also good for the future development. If you want to look at reclamation, if you want to look at expanding your wells, your well pads, your facilities, you have that data already to continue to plan off of. This data doesn't just go to the surface land or one department. This is data that can be shared throughout our client's company and really used to make good decisions off of. And the biggest thing is the reduced cost. So conventionally, our average cost per well was $64.20. Using the UAV and the aerial survey, we were actually able to get down to about $2,300. That's a big difference. And then so the average cost reduction is 65%. Pretty awesome.
Man, that's a huge difference. Is there any reason you wouldn't use aerial survey?
In my opinion, I just don't see the reason why to go back to the conventional. Again, all of this is a tool. It's not something that, it's some groundbreaking thing. It's a tool. It's a way to collect data. And, the biggest thing is you can reduce everything in that sense, right? Your cycle times to getting approved permits, your cost, you save immensely. And then you're getting more data for the same cost. It's really, in my opinion, it's the way of the future.
Yeah, that makes sense. So we do have a couple questions that came in during the webinar. The first one is, how do we transfer the data?
I briefly touched on it earlier. We can either serve it up through Portal for ArcGIS for visual, and then from there we can add hyperlinks that clients can click on to download the data themselves. We also have those shape files in geodatabases, which we can just send to the client if they need them.
Okay, and then let's see. Does Ascent store the data, or does the client?
So all of our data is stored in our central SDE database, which we then can extract and give to the client.
Okay, and then can you go over the accuracies again?
Yeah, so one of the big things about this is it's spatially accurate data. So a lot of providers out there right now, you can go out and get updated aerial imagery with a high resolution camera, and that's great. The biggest thing about this is that horizontally, the data is dead on accurate. Vertically, this data is between 1/10 and 3/10 of a foot. So what that means is that you're able to engineer a location from this data. It's placed in the real world. So all of the exhibits that go into an exhibit package for getting approved permits or